Engines. Start. 4-stroke petrol. 2-stroke petrol. Diesel. Click an engine to select. 4-stroke petrol engine. Find out about the parts. Watch an animation. How it works. Different engine arrangements. Gallery. Back. 4-stroke petrol exhaust valve, inlet valve, spark plug, cylinder. Piston. Connecting rod. Crank. Oil sump. Back. Parts department. The inlet valve. The inlet valve is pushed down on its spring to open up a way for the petrol vapor and air mixture to go into the cylinder. Back. Cylinder. The cylinder is where the fuel is burned. Parts department. Cylinder. The cylinder is where the fuel is burned. The total volume of the cylinders is known as the engine capacity. Back. Parts department. Connecting rod. The connecting rod connects the piston, which is moving up and down in a straight line, to the crank, which is rotating. Back. Parts department. Exhaust valve. The exhaust valve is pushed down on its spring to open up a way for the burnt fumes to leave the cylinder. Back. Parts department. Spark plug. The spark plug creates a spark at just the right time to ignite the petrol vapor and air mixture. Back. Piston. The piston moves up and down inside the cylinder. Parts department. Piston. The piston moves up and down inside the cylinder. When the fuel explodes, the piston is pushed down. Back. Parts department. Crank. The crank is the first part of the engine to move with rotating motion. Back. Parts department. Oil sump. The oil used to reduce friction and keep the engine running smoothly collects in the sump at the bottom of the engine. Back. Parts department. Fuel injector. In a diesel engine, the fuel is injected through these devices at just the right moment. Back. How it works. There are 4 stages to the cycle. Induction. Compression. Combustion. Exhaust. There are 4 stages to the cycle. Click on each engine to find out about each stage. Back. Induction. The inlet valve opens, the piston is moving down. A mixture of petrol vapor and air is sucked into the cylinder. The inlet valve closes. Back. Compression. Both valves are now closed, the piston is moving up. A mixture of petrol vapor and air is being compressed, squashed. Back. Combustion. Both valves are now closed. The spark plug makes a spark which explodes the fuel. The piston and the connecting rod are pushed down, turning the crankshaft. Back. Exhaust. The exhaust valve opens, the piston is moving up. A waste fumes are pushed out of the cylinder. The exhaust valve closes. Back. Different engine arrangements. Inline. Most engines of 4 cylinders arranged vertically in a straight line. V6. Some more powerful engines have 6 or 8 cylinders arranged in a V shape. Flat 4. Some engines of 4 cylinders arranged in a flat horizontal way. Click each engine to see animations. Back. Gallery. 4-stroke petrol engines are usually used in cars, small propeller planes, and larger pleasure boats. Back. 4-stroke diesel engine. Find out about the parts. Watch an animation. How it works. Gallery. Back. 4-stroke diesel fuel injector, air inlet valve, exhaust valve. Cylinder. Connecting rod. Piston. Crank. Oil sump. Back. How it works. There are 4 stages to the cycle. Induction. Compression. Combustion. Exhaust. There are 4 stages to the cycle. Click on each engine to find out about each stage. Back. Induction. The inlet valve opens, the piston is moving down. Air is sucked into the cylinder. The inlet valve closes. Back. Compression. Both valves are now closed, the piston is moving up. Diesel fuel is injected into the cylinder just before the piston reaches the top. Back. Combustion. Both valves are now closed. There is no spark plug. Instead, the air has been squashed so much that it is hot enough to ignite the fuel straight away. View video clip. The piston and the connecting rod are pushed down, turning the crankshaft. Back. This is how a diesel engine ignites the fuel. These are video clips which show a piston being pushed very rapidly down a glass tube. The squashed air heats up so quickly that a small piece of tissue paper at the bottom of the tube bursts into flames. This is how a diesel engine ignites the fuel. Click the pictures to play. Back. Exhaust. The exhaust valve opens, the piston is moving up. A waste fumes are pushed out of the cylinder. The exhaust valve closes. Back. Gallery. Until recently, diesel engines were only used on big vehicles. Nowadays they are quite common in small cars. Back. Two-stroke petrol engine. Find out about the parts. Watch an animation. How it works. Is two-stroke better than four? Gallery. Back. Two-stroke petrol. Spark plug. Piston. Cylinder. Connecting rod. Crank. Back. Upstroke. Compression. How it works. Downstroke. Combustion. Upstroke. Compression. The two-stroke engine fires once every revolution, whereas the four-stroke only fires once every other revolution. There are just two parts to the cycle, the downstroke and the upstroke. Click on the pictures above to find out about each stroke. Back. The downstroke. Combustion. This starts when the spark ignites the fuel, pushing the piston down. Soon after starting to move down, the exhaust port is uncovered and the exhaust gases rush out. In a two-stroke engine, the fuel, air, and oil mixture surrounds the crank. So as the piston moves down, it squashes the fuel mixture. Continue. The downstroke continued. As the piston moves down, the inlet port is uncovered and the squashed fuel mixture rushes into the cylinder. Notice that at this point both the exhaust and inlet port are both uncovered. It is possible for some fresh fuel to pass straight out of the exhaust port. Back. The upstroke. Compression. As the piston moves up, it begins to squash or compress the fuel mixture above it. Continue. The upstroke. Compression. Once the inlet port has been covered, the rising piston will cause a partial vacuum in the crankcase below it. The drop in pressure in the crankcase causes the reed valve on the inlet to be sucked open. A fresh fuel, air, oil mixture can now enter the crankcase. Back. Is two-stroke better than four? Click on an expert to find out more. Back. Is two-stroke better than four? A two-stroke engine fires once every revolution, whereas a four-stroke engine only fires once every other revolution. This means it is a lot more power. If you need a lightweight engine with a lot of power, then two-stroke is much better. This is important if the engine is on something that you have to lift, like a petrol hedge trimmer or chainsaw. Back. Is two-stroke better than four? A two-stroke engine doesn't have any valves and all the parts needed to drive the valves. With fewer moving parts, the engine can be lighter, and will be more reliable. This is important in small portable engines, and makes two-stroke engines ideal for scooters and small motorbikes. Back. Is two-stroke better than four? In a two-stroke engine, the fuel, air mixture is to surround the crank. This means there is no pool of oil in the sump to lubricate the moving parts. To overcome this, special oil has to mix with the fuel. This means that the engine will work equally well at all angles, even upside down. Important for small handheld machines like chainsaws. Back. Is 2-stroke better than 4? In a 2-stroke engine, the fuel air mixture is to surround the crank. This means there is no pool of oil in the sump to lubricate the moving parts. To overcome this, special oil has to mix with the fuel. This means that the engine will burn quite a lot of oil. 2-stroke engines are often quite smoky. This doesn't go down too well when we are trying to avoid pollution. Back. Is 2-stroke better than 4? Remember that there is one part of the cycle when both inlet and exhaust port are both open. New, unburnt fuel can go straight out of the exhaust. This means that 2-stroke engines waste a lot of fuel. If you had a 2-stroke engine in your car, you wouldn't get very many miles to each liter of petrol. Petrol which is leaked out of 2-stroke boat engines is often seen floating on the water. All of this makes 2-stroke engines very environmentally unfriendly. Back. Gallery. 2-stroke engines are ideal for small machinery which may have to operate at different angles and where it is important to keep the weight down. Back.